Hi everyone, welcome to Keyword Spotting with the Arduino Nicla Voice. I'm David Tischler, the Developer Program Manager here at Edge Impulse. Today, we're going to walk through who is Edge Impulse. We'll take a look at the Nicla Voice hardware. We'll talk about what is keyword spotting. We'll build a keyword spotting machine learning model and then deploy that model onto a Nicla Voice hardware. But first, let's take a quick glance at what a typical machine learning project pipeline looks like. It consists of 4 phases: collect, design, test, and deploy. And in the context of our webinar today, what that means is collecting sample keywords, recording ourselves saying a keyword, building a model that can recognize that keyword, measuring the accuracy of detecting the keyword, and then, if we're happy with the results, deploying that model onto the Nicla Voice. Let's begin with who is Edge Impulse? At the highest level, Edge Impulse is a platform that allows you to build machine learning models and deploy those models onto Edge AI devices. In the context of our 4 phases that we just discussed, let's take a look at the first one, collect. Collect is the capability of uploading or ingesting data to create a data set. And you can use the Edge Impulse platform or the Edge Impulse Studio, as shown here, to connect to an S3 bucket or other cloud location, to ingest data directly from devices, or to upload pre-existing data from your local machine. Design is where you'll go through the steps to build your machine learning model. This consists of a processing block and a learning block, and will, at the end, create that algorithm that's going to get deployed. But before you do that, you really want to test it to make sure that it's working as you expect it to and that your accuracy meets your project's needs. And then in the final phase, Edge Impulse will allow you to deploy that model with ease onto your target hardware. Today, we're going to use an Arduino Nicla Voice, but there are other targets available as well. Now let's take a closer look at the Arduino Nicla Voice. The Nicla Voice contains a Nordic Semi NRF52 MCU, a Sentient NDP120 neural decision processor. That's what we'll use later for the keyword spotting classification. It also contains a microphone, 6-axis IMU, 3-axis magnetometer, 512K of flash and 64K of RAM, 16 megs of flash for storage, and the entire thing is only 22 by 22 millimeters and 2 grams. It's tiny. Here it is on my desk, and you can kind of see it's really only the size of a couple of keys on a keyboard. The Nicla Voice can be purchased online from the Arduino store or from a variety of other retailers and resellers as well. And as a fully supported Edge Impulse device, it's available for deployment directly from the studio, and we maintain and support firmware for the device. So we've made it through who is Edge Impulse and the Nicla Voice hardware. Let's move on to what is keyword spotting. Next, let's take a look at what is keyword spotting. Keyword spotting is a system that can recognize audible events, usually a voice, through audio classification. For example, you might be familiar with Hey Siri or OK Google. It's the ability to recognize those keywords. And that includes even in the presence of background noise, chatter, a television, a car driving by, whatever the case may be. And an action is taken upon the detection of the keyword. In the context of OK Google or Hey Siri, what typically occurs is your request, your query is sent up to the cloud for analysis, maybe research, could be information that you have requested. And those results are then sent back down to you. And that all happens very quickly. But it can also trigger physical actions, such as opening or closing a door, turning on or off an appliance, or sending an alert, a message, an email, a communication of some sort. Or you could even interface with other applications and services, like setting a reminder, adding a calendar invite, or even completing a purchase. And the Nicla Voice can perform keyword spotting, again, due to its onboard sentient NDP120 in a tiny form factor, inexpensively. So let's give it a try. Before we begin the actual construction of our keyword spotting model, I want to make two quick points. The first is that I'm going to walk you through all of this process here using slides first before we go and do a hands-on demo. The second is that you actually have two options when thinking about how to build a project. You have the ability to create a new project, which does not have any data, so you will need to add your own. No devices are connected, so you would need to add your own. And no impulse has been created, so you'll have to go through the steps to create that machine learning pipeline. Now, those are all very simple to do inside of the studio, but in the case of this webinar, I'm going to use a cloned project. And the reason for that is that the data set will be imported from the existing project. We'll still need to add our Nicla Voice to the project because we will want to do a little bit of data collection of our own. But the impulse is also already designed. And again, these are simple tasks to achieve in the studio, but it's going to save us a bit of time. So we'll do a cloned project for this webinar. If you were to create your own project, the process is very simple. You go to studio.edgeimpulse.com and you click on Create New Project. You give it a name, and then you can choose from Developer or Enterprise. Developer has a lower job size limit and training time. Enterprise allows you a few extra features such as collaboration, custom blocks, and the ability to run larger jobs. For the purposes of this webinar and building a keyword spotting model, Developer will be fine. Developer is free. You can just click Create New Project, and you'll be brought to the dashboard. You can see here on the dashboard, you've got a couple of tutorials that you can run through, such as gesture recognition, object detection, or audio classification. You can collect new data, add existing data, or even upload your own model if you happen to already have one. Connecting a device does require a little bit of installation. You'll need some CLI tooling, and you'll want to install the Edge Impulse firmware on the Nicla Voice. Once the firmware has been installed, you can run the CLI daemon, and the Nicla will connect to the studio. That's all documented. You can find it at that link, and I'll go ahead and put the link in the description of the video as well. You can see when starting out in a new project that no device has been connected yet. But if you run the daemon, as we just discussed, the Nicla Voice will then link directly to your studio. Now, collecting data. Again, as I mentioned, we're going to clone a project, so we're about to get a lot of data. But to collect data, as we discussed earlier, you've got several options. You can upload existing audio files directly into the studio. You can record new audio samples from within the studio. You can upload files via the CLI. You can connect to cloud locations like S3 or Google Cloud Storage. You can clone a project, which is what we're going to do. Or you can run the ingestion service, which will capture data and feed it into the studio directly from a device. Cloning a public project is very simple. All you'll need is the URL of the project that you would like. URLs can be found over on the Edge Impulse website, which has a page devoted to searching and filtering for public projects. I found this one here that has about 10,000 recordings of the words go and stop. So that will be perfect for a keyword spotting model. To clone it, all you have to do is click on Clone this project at the top right. Choose between developer or enterprise. As we discussed, developer will be just fine for the webinar. Provide it a name and click Clone Project. It will take some time to clone because, as I mentioned, there's about 10,000 recordings in this one, so it does take a little while. At the end, though, you'll see that the clone has succeeded, and on the left, you can click on Data Acquisition. You'll see now that there are 2 hours and 54 minutes of recordings and about 2,800 goes, 2,800 stops, and 3,900 Z_open set, which is background noise. So this should be pretty good for our keyword spotting model. At the top, you can also click on Data Explorer, and you'll get a visual representation of how your data is distributed. We can see here that there's some outliers. I see that some of the stops have bled over into the go, and some of the open data set or noise is amongst the stops. But generally speaking, this looks pretty good from a clustering perspective. You can always drill down and investigate those individual artifacts to see if maybe they were mislabeled, or if they're just outliers. You could even delete them from the data set if you think it's going to affect your overall performance. But this looks pretty good. Now, you can also click on an item and listen to the recording. I did that for some of them, and I heard different voices, different accents, different intonations of the go and stop keywords. But I want to actually add some of my own voice to the data set. So what you do then is connect your Nicla to the studio, like we showed earlier. Choose a sensor. We need the microphone. Provide a label. I'm going to record stop, and click Start Sampling. You could also use a phone or your computer, but I want to use the microphone directly on the Nicla, since that's where I'm ultimately going to be running my inferencing. When you're ready, you can click on Start Sampling and speak into the Nicla Voice. You can see here one of my samples, me recording the word stop. Now, I also set a 5-second window to say the word stop, which actually gave me time to say it 3 times in this particular case. I can drill into one of my samples and draw windows around each of the individual stops in that data object and click on Split at the bottom right, which will then give me 3 unique data points. And you can see the length was 1 second for each of those. Next, we'll move on to building an impulse. Now, ours came pre-configured because we cloned a project, but we can take a quick look at the 3 main building blocks. All impulses will have an input block, a processing block, and a learning block. Ours already has time series data as the input block, audio sentient as the processing block, and a neural network Keras classifier as the learning block. You can always add additional blocks, and you can also research all of this over on our docs, which I'll put the link to again in the video description. But here's what it looks like when you click on add a processing block or add a learning block. So you can simply choose which one you want, and you might even be able to experiment with a couple of different ones to see how your model behaves. But knowing that ours came pre-configured, we're going to leave it alone and just click Save Impulse. Next comes feature generation. In the parameters, choose the NDP120 and click Save Parameters. And you can kind of see here what that raw features extraction is going to look like. Next comes Generate Features, and you'll get a visualization of the extraction from the data set. Again, it's pretty good clustering. I do see that some of the noise data set has bled over, and there's certainly some stops amongst the goes, but this looks like it's clustering pretty well, so we'll move on with it. Finally is the neural network classifier. This is where we will actually perform the model training. There's a lot of options here. I'll show it to you in one moment. There's also an expert mode if you want to modify the raw keras. Again, all of it is documented. And depending on the size of the data set, it can take a while to train. But it's easy. Just click Start Training when you're ready. Here's a screenshot of what that page looks like. So you can see there's quite a few variables that you can tweak and modify here. But at the end, we'll come away with a trained model. Again, it may take a while for the training to finish, depending upon how many training cycles you've run. But as you can see here, the job completed, and we came back with 97.6% accuracy, which is pretty good. I can see again the visual representation of the Feature Explorer, and there are some misclassified data points. But overall, it seems like it's working pretty well. Go, stop, and background noise are all in the 90% range. So let's go ahead and test the model. Now, model testing is a little bit different than what we just saw a moment ago. During the data collection phase, a portion of your data should be set aside and not used in the model training. This set aside data, because it is unseen, is great then for testing the model. This was done for us when we cloned the project. You can experiment with the various thresholds. We generally recommend 80-20 split, as you can see here on the screenshot. And the data set that we used was 79% split on the go keyword, 80% on stop, and 79% on Z underscore open set. So pretty close. On the left, you can click on Model Testing and then click on Classify All. And what it will do is then run through using the model that you just built against that set aside data. And you'll come away then with results to see how well it performed on unseen data. So we've made it through who is Edge Impulse, the Nicla Voice hardware, what is keyword spotting, and the creation of the ML model. The last phase is going to be deploying the model that we just built onto the Nicla Voice. Let's take a look at that. On the left, you click on Deployment, and you can begin searching for the type of hardware that you're using. Because we used a sentient audio block in the impulse creation, the studio knows right away that we're using either a Nicla Voice, a sentient TinyML board, or gives you the ability to just create an NDP120 library. I'm going to choose the Nicla Voice and click Build Model at the bottom. It will start creating the firmware, and at the end of the process, we'll download a zip file that we can then use to flash our device. Over in my development VM, I have downloaded that file, unzipped it, connected the Nicla Voice via a USB cable, and I can flash it now using one of the OS-specific scripts that was in the zip file. There's Mac, Windows, or Linux utilities for flashing the device. Once it has been flashed, I can then use the Edge Impulse Run Impulse command to start inferencing locally on the Nicla Voice. Let's go ahead and try this hands-on. Now that we've seen what the process looks like from end to end, let's go ahead and give it a try. First, I've already cloned that public project because, as mentioned, it does take a little while. There's about 10,000 samples in there. So to save some time, I've got it ready to go here for us. On the left, I can click on Devices, and we can see the Nicla Voice was connected, but at the moment says not connected, that little orange bubble there. We can solve for that pretty easily, though, by going over to our development machine and starting up the Edge Impulse daemon. That will take a moment, and once it's complete, we'll see that light change from orange to green in the dashboard. And there it goes. Now in the dashboard on the left, I can click on Data Acquisition, and we see that our 2 hours and 54 minutes of data has come along for the ride as part of the clone. And we can see a couple of extra samples in here that I recorded the other day, but I want to go ahead and add one more right now. I'll click on Start Sampling, and it'll be a little bit small in that terminal over on the left, but we should see some activity there as well. Stop. And now that recording will get uploaded into the studio. This will take just a moment to retrieve the data from the device over USB, then upload into the studio. And there it is right there, we can see. So it's been added. Next, let's take a look at our impulse design. And as mentioned earlier as well, this is already configured for us. So I'm not going to make any changes here, but you can, of course, add additional processing blocks or learning blocks if you want to explore with that. Now, I'll save the impulse, and I'm going to come over to the NN classifier, the neural network classifier. This is the actual training portion. Again, I'm going to leave the defaults alone, and I'm going to click on Start Training. This will also take a little while, so I'll pause the video while it's running, and then we'll come back to it once it's been completed. First, let's go ahead and start our training. Okay, now that our training is complete, let's go ahead and build some firmware for the device. To do that, we'll click on Deployment on the left. Give this a moment to load. And in our search field, we can see it has narrowed down our selections to the two Sentient library or Nicla Voice that is available. I'm going to choose the Nicla Voice to build a full-fledged firmware that we can flash straight to the board. Click Build, and we'll start the creation process. This will also take some time. So again, I'll pause the video here and return as soon as it's ready. Okay, our build has finished and our firmware has been downloaded to our local machine. To save us just a moment, I've already copied it over to my development machine and unzipped the file. You can see the contents of the file contain flashing scripts. We'll use the flashing script here to push the firmware and model onto the Nicla Voice, which I've got connected to the computer via USB cable. This will take a couple of minutes, but rather than make you wait here, I will pause the video and resume it once it's finished. Looks like the model is flashed, so let's give it a try. We'll reset the board and we can use the edge impulse run impulse command. Go, go, stop, go. Go, stop, go. So there you have it, keyword spotting on the Arduino Nicla Voice. Let's conclude by returning to our slides for a few final talking points. You just saw that we downloaded a binary, flashed it to the Nicla Voice, and ran the inferencing that way. But a library was also available. You can use the library to integrate and build out your own custom applications. You can also modify the firmware we used, which is open source. It's available on GitHub. Again, we'll put the link in the description. And then when we think about building your application, what exactly is your specific use case? When I ran the inferencing, you saw the LED light up when I said go or stop. But beyond lighting an LED, what you can do is control servos, start and stop motors, appliances. You can turn them on and off, perform functions in applications like we discussed earlier, send messages over BLE, integrate with other sensors, and more. So you just need to think about how do you want to make use of the inferencing and how do you want to integrate that into the bigger picture that is your application. So that's it for me. If you do have any questions, feel free to reach out. You can see my contact information here. And thanks for watching our webinar.